what we're looking at today is we're starting 3-5. We had started 4 on Wednesday, okay? And with that homework for lesson 4, which was the equations of lines, that's due tonight. At the start of this, there's a bit of review. So we'll go over those types of questions that's gonna be on your homework. And then we will start in on proving lines parallel, which is kind of circular reasoning. We previously learned that if we had certain relationships, you know, because we had parallel lines and we had this type of relationship, then we had the angles that were congruent. Now we learn if they're congruent, okay, and they have this relationship that proves things parallel. So we kind of backtrack. So let's look at some review here. And looking at what we need. No, I'm in completely wrong spot, and I don't know why it went all the way there. Wow. That was weird. Because I should be right here. Okay. So starting here, ladies. It gives us a slope and a point, and they want us to write the equation of a line in point-slope form. You want to do it? Mm-hmm. Okay. Go right ahead.
Okay.
So point-slope form, we're making use of one of the points, an x and a y, and the slope 3/4. Okay, so that's y subtract y1 equals the m times x subtract x1. So she's already taken like an extra step in there. It is y subtract y1. She said y plus 2 because that was y subtract negative 2, which became y plus 2. And she has the 3/4 and the x minus 5.
Do you see that x?
Which one's matching?
C.
We say C. Oops. What? What? It's just gonna misbehave. There we go. So y plus 2 is equal to 3/4 x minus 5.
Can I do this one?
Sure. So still we have a slope and we have a point.
Ow. Shocked me.
Yeah, she's just kind of mixing what she's doing. She decided at first not to write out that base equation. She
You
was
know
just going to
what?
start plugging things in. That's good.
And you know what? Oh, was I supposed to?
That's fine. So simplify that a little bit. And is that one of our choices? That appears to be choice
Okay.
E.
So you don't have to distribute that afterwards?
It just depends. Okay? This is correct in this point slope form. This is perfectly fine. If they wanted you to get it to the y equals mx plus b form though, I would have to keep going further so that y was on its own and that we'd have something x plus.
Oh, okay. So if they said,
This was just asking for point slope form.
okay.
That was a good question.
So they'll tell us whenever they want it.
As I keep wanting to simplify it too, but that's not what they
Yeah.
asked for. Okay, slope intercept form. I think it's Carson's turn.
Okay. Oh no, can I do this one?
No, no, Carson can do
She's
it.
literally.
Carson can do it.
Gotta make sure you know. Get up there.
Come on, Carson.
But I don't volunteer y'all for stuff.
Right. That's
Uh,
what they
Hey, well, they didn't volunteer you, I volunteered you. Here's the format.
That was ghetto.
Oh, that was? So sorry. I'm so sorry.
So we have a slope and we have a point. Plug it in.
I don't know, I just have to rewrite this again.
Okay. If that's what it takes, go right
So we
ahead.
have the slope and we have the points.
Uh-huh. So y subtract what?
Oh, we using these first?
Uh-huh. Y subtract. Because this is my y1, this is my
Yeah.
x1.
Let me write that, sorry.
Yeah, no, I would. Sometimes I need to. Otherwise I mix them up.
Yeah.
Looking fabulous. Okay? So if we start looking at this and comparing it to this, does it look like we have an answer? Y subtract 2.5 equals negative 3x. And it doesn't have this because negative 3 times 0 is,
Zero.
so the choice is,
Doesn't have zero. Oh, wait, why does it not have zero? You still. Oh, because you multiply. Oh, yeah, you're right, you're right.
You don't even have to. You don't even have to do all
oh,
that.
hey,
2.5
okay,
times.
hold on. I understand. Honestly, at first I thought he was saying the right thing too. What did they ask us for?
Slope-intercept form. You don't even have to because the y-intercept is right here because x
Yeah,
is zero.
there is that too. Okay, so 2 ways. You can calculate this, and although this is correct in the format of solving, slope-intercept form means I have to get it into this form at the end.
Oh,
Slope-intercept.
so I can just.
So although this is correct in the way of, yes, I'm doing the math right, doing it so I get slope-intercept, I need the y equals mx plus b.
Oh.
So this is
I have to put
correct,
it in this form.
and this one was close, but I needed
In
it
that
to be in
form.
that form.
Okay.
But here's the second thing, and you got that completely right. Now she shows us something else. She says, hey, I need slope-intercept. Here's my slope. I already know the intercept.
Yo.
Because this here, if I were to plot that point, is 0x and 2.5 y. That means that it's on the y-axis. This is the intercept, the b. So all I had to do was take this and go y is equal to negative 3x plus 2.5. But the thing is, you don't always see it. I didn't. The first time through, I didn't. Okay, last class, I had to have another student point that out.
What, the zero thing?
Yeah,
I pointed it
just
out
like you
too.
did.
Wait, so you saw it twice and you still didn't see it the first time?
No, I didn't see it the first time. This time I knew, but does that make sense?
Yeah.
Sometimes you might notice it and you can take the shortcut. But if you don't know, or it's okay to not have the shortcut.
So this would be point slope form though, right?
Yes, that
Okay.
is more of a point slope form, and this is slope intercept.
I'd like to share
Just trying to
something.
make sure.
So on the homework for
Yeah.
numbers 47,
Which homework?
actually you know what, wait, 3-4 homework.
3-4 homework?
There was one of the questions, number 25 and 27, they had us solving, and I was like doing all this work, and then I realized that the y value on both of the points of
As
the
an
us were
intercept?
the same. So
Ah,
I could have
okay.
just put y equals that.
Okay.
So I did all that work, but I did erase it. And
Yeah,
just put it-
sometimes that happens. Sometimes you realize you've done more work than you needed to because you find a way to link it later on. Okay, how about this one? We need to put this into slope-intercept form. Again, that gives us a point and a line. Sorry, point and a slope. I'm gonna do this just to try to speed it up a little. You can tell me.
Okay.
So what do I put?
y plus 6, my bad.
Yeah, y plus 6, because that's a negative.
Negative 1/2 times x minus 4. Then you distribute the negative 1/2 to the x and the 4.
Why do I have to do that?
Because you're putting it in slope-intercept form.
Because I have to get it into this form. negative 1/2 x. Negative 1/2 times negative 4 is positive 2.
Yeah.
This is negative 1/2 times negative 4.
Over 1.
Yeah, or I could say negative 4 over 1, I agree. So 4, 2, negative, negative, it becomes a positive 2. So y plus 6,
And then you subtract the 6 from both sides. So yeah.
and so our answer is B. It matches. Okay, how about this? What do I do?
Okay, so first you gotta find the slope.
So first I gotta find a slope, and then once I find the slope, what do I do
So
next?
11 minus 5. That's 6.
She's like, I just need to find the slope first. So
That's
M
2. The slope is 3.
rise over run.
The slope is 3.
So we have 11 subtract 5, 3 subtract 1, that's 6 over 2, which is 3.
So why?
Now how am I going to get a line from the slope?
You do the,
Take one of the points,
yeah, plug it in.
y subtract 5 is equal to my slope times x subtract.
What form is that one called? Standard?
This
Point
one,
slope.
point slope, this is the point slope form.
So what is
Point
the
slope.
y equals mx plus b?
That's what the
That's
y
slope
intercept.
intercept.
Okay, so this is point slope.
Yeah.
The other one is just slope intercept.
Yep.
Okay.
You just have to look, am I including a slope and a point? Am I including the slope and the intercept? Okay, so at this point, y minus 5, I don't have anything that's y minus 5. So I'm gonna have to distribute 3x minus 3. Add 5 to this side. Something's not right.
Try the other one.
Try, what, no, it's not the matter of the point. Here's our slope. Y subtract 5, 3x minus. No, my brain just did a weird thing. I was thinking I need to subtract and subtract. I need to add 5. So if I add 5 to this side,
It's a -2.
add 5 to this side, no, it's gonna be positive 2. Negative 3
Oh.
plus 5 equals positive 2. So this is where, like, as soon as it doesn't jive, you go, where did my brain make the wrong connection? And in this case, I started looking for an 8 over there, and I'm like, oh, wait a second. This is add 5, add 5. I'm not going to get 8. It is negative 3 plus 5, which is negative 2. Okay. Why is this the case? Why is it that A is the equation that is parallel to the one in the question?
Wow.
How am I going to know that this one and this one are the parallel lines?
Because the slope is the same.
The slope is the same.
But you know what? The slope is the same on B2.
No, it isn't.
Yes, it is.
B
No, it isn't.
negative.
Oh.
Positive slope, negative slope. They would be crossing. Not as a perpendicular, but they would be crossing. So even though it has the same value as far as the numbers, that negative changes everything. It will have the same sign if they are parallel to each other. They're both going to be positive, or both of them are going to be negative. Or they're both going to be 0 if we have two horizontal lines, right? How can I find the slope of a line perpendicular? What would be a perpendicular line? of these perpendicular?
D.
Yeah.
D would be, because I have to take this, flip it, and change the sign.
So it would be 4/1.
So this one here is perpendicular, oops. This one here is perpendicular, and this one here is parallel. So now we finally get on to some new stuff. Okay, first off, we learned how to find the slope of the line and determine what was parallel and what was perpendicular and what was neither. Now we're going to take those angle pairs that we recognize because of the parallel lines and use those angle pairs to prove that two lines are parallel. It's just going to come full circle. So we have additional postulates. You need to have this handy. Yeah, someone asked today, well, how many of those are we going to use? Well, there's pages and pages and pages. We keep adding to it, just like learning new words, okay? But in this case, we're able to look things up. So at this point, we're at postulate 3-4, which is going to be, all the way back here. And we look at converse theorems as well, okay, which is going to be on our next slide. So here, rather than saying, hey, I have parallel lines and we have this relationship so they're congruent, that's what we did previously. We said, okay, well, A and B are parallel and they had this sort of symbol saying that they are parallel. And so 1 and 3 were corresponding, so they were congruent. This goes the other way around. This one says, hey, since I know, say for example, that 1 and 3 are congruent, that this is the same measure as this, and because they are corresponding, so because they're corresponding and they're the same size, I know A and B are parallel. Okay, so we're kind of doing this situation where, hey, if we have A, then we get B. Now we're actually able to circle back and say, well, if we have B, then we have A. We're doing this circular sort of logic, but we have additional proofs that will allow us to prove that. Okay, if 5 and 7 were congruent, okay, they're also corresponding, they're congruent, A and B are parallel. Does that make sense? So this is the converse of the corresponding angles postulate. It proves the converse, that we can prove parallel lines rather than starting with them. Parallel postulate says that if I have a line, and if I have a point that's not on that line, okay, there's only one line that goes through that point that's going to be parallel to that first line. Okay, so that's the parallel postulate. Again, we're looking things up on our cheat sheet to go, hey, how can we remember this? How can I use this? Okay, we have new theorems that are the opposite of before. You notice that all of these are converse. They're conversely related. Saying if I have two lines that are cut by a transversal, and I know their relationship, like alternate exterior, and these are the same size, that proves P and Q congruent. Here, if I have consecutive interior angles like this, okay, and these two angles are supplementary, that proves P and Q congruent. Alternate interior angles, okay? If I have these alternate interior angles, because this is my transversal, and these are the same size, it proves these lines congruent. and this last one with the perpendicular. Okay, if two lines are perpendicular to the same line, then they have to be parallel. So you see how this kind of circles back? Because we could say this leads to this, that same thing that we proved leads back to proving that first thing true. So let's make use of that. We are given that angle 1 is congruent to angle 3. Okay? These two are congruent and cut by this transversal here. What type of angles are they? What's their relationship? Angle 1 and angle 3 are corresponding. We can't have parallel angles, we can have parallel lines. Okay? We have corresponding angles. They're on the same side of the transversal, same side of these lines. Because they are the same size and they're corresponding, I know that they prove A and B parallel because of the converse of the corresponding angles theorem. Okay? The corresponding angles, the converse of the corresponding angles theorem says if these are congruent and they're corresponding angles, that proves A and B parallel. We don't know anything about C because we didn't deal with any angles related to C. Okay? So we still have the same transversal, but now they tell us that angle 4 is 100 and that angle 1 is 103. What type of angles are these? Alternate what?
Interior?
Alternate interior. Now, in order for lines to be parallel, what would their measures need to be if they're alternate interior?
The same?
They would need to be the same. Are they? No. So this says with line C and line A, they are not parallel. Okay? Because they don't have the same measure. They're alternate interior angles, but since the measure of 1 and 4 are different, they are not parallel by the converse of the alternate interior angles theorem. Okay, how about this one here? It says that angle 1 is congruent to angle 5. So this one is congruent to this one. What's the relationship between those two angles?
Corresponding?
They're corresponding. What lines is it attached to? L and N. It says nothing about N. Okay, so I'm expecting that it doesn't have anything to do with N. Both of these have N. Can I tell that L is parallel to N?
Yes.
Yes. I can tell that because I have corresponding angles, and these corresponding angles are congruent, and if they're congruent, they're the same measure, then line L and N have to be parallel. Okay, so answer A. Okay, now we're given that the measure of angle 4 is 105. Stuck. So this one here is 105. And at the measure of angle 5 is 70. Can I prove any of the following? No. Why?
Because the angles are not corresponding and they're not congruent.
They're not congruent, they're not corresponding. What type of angles are these?
One's obtuse and one is acute.
Okay, how about angle relationship between them? What's the relationship? They are,
On the same.
they are.
line.
So these ones are consecutive interior. And what do we look for consecutive interior? Normally, we want them to add up to 180. They're supplementary to one another. Okay, so the converse of the consecutive interior angle theorem will tell us, no, these do not add up to 180. So we can't say that M and N are parallel. We have that it's not possible to prove these parallel. Only, like if this were a 75 though,
Then
yes, it
yeah.
would prove M and N parallel.
Oh, okay.
Okay? Find the measure of Z, Y, N. Let's see what that is. Z, Y, N. They want us to determine this angle right here, Z, Y, N. We need to determine what this is to prove that PQ and MN are parallel. For these two lines to be parallel, these alternate exterior angles need to be congruent, the same measure. So if we say 7x plus 35 equals 11x minus 25, that says these measures are exactly the same. So we need to find what x is to determine, well, we have to solve for x and then plug that back in to determine what the angle is. So 7x, 11x, let's bring the 11 over here. We're going to subtract 11x, subtract 11x. So it's going to be negative 4x. We're going to subtract 35, subtract 35. Negative 60 divided by negative 4. I end up with x equals 15. Plug that back into this equation. 7 times x plus 35. So that's 7 times 15 plus 35. So that's 95, I believe. $15 times 7, 105. Tells you how confident I was. Equals 140. So this is 140, this is 140. And we know what the measures are with the x. We know that they're alternate exterior, so they should be congruent. We substitute in, we solve for x. We're left with x equaling 15, and we can solve for the angle by plugging that 15 back in. So we're left with that angle is 140. It says verify the angle measure by using the value to find the other angle. Okay. Plug 15 into the other side of things and you're still going to get 140. Since they have the equal measure, they're parallel. Okay. How about this one? We need to determine what the x is so that This line, GH, is parallel to RS. And they give us this angle. We want these two angles to be congruent because they're alternate interior angles. So we just do the same thing. 7x minus 3 equals 9x. Subtract 21. Okay? I'm going to bring this the other way this time. We're going to say that this is subtract 7x, subtract 7x. Add 21, add 21. And x is equal to 9. This time they didn't ask us to find the angles, just find x. And that's what we did. Okay, in this case we're saying, hey, in order for these to be parallel, I need these to be congruent, so let's solve for this. Okay, and we're at the very end. This is our last problem. It says, in the window shown, the diamond grid pattern is constructed by hand. Is it possible to ensure that the wood pieces run in the same direction are parallel? If so, explain. If not, explain why not. Can we tell if these things are parallel? What would we need to do to determine that? We need to find some relationship between different angles, whether it's corresponding, alternate interior, alternate exterior, consecutive interior, and measure them. And if we find that we have congruent angles, the same measure between, say, corresponding angles, we can prove the different slats parallel. If I were doing consecutive interior, then those two would have to add up to 180. So here's the answer. Measure the corresponding angles by 2 consecutive grid lines. Okay. If these angles are congruent, then the grid lines that run in the same direction are parallel by this converse of the corresponding angles postulated. Is it possible to prove any of those parallel or perpendicular? We have 4 right angles. This is going to use the last one that we learned about with those right angles. If this is a right angle and this is a right angle, then the converse of the right angles says that these two are parallel, which says that all of these are true, because we have all of these right angles. Okay? That's the homework for Monday. Get 3-4 done tonight, 3-5 done for Monday.